Hello, good morning to everyone. Today we are going to have a special program, online interactive class in applied science. And I'm very grateful to our department for giving me this opportunity in order to conduct the class, not only in a small room, but all over, in other words, worldwide, I can say. And today, I am very glad in a particular sense. It is because I started my career in 1988 in KRPET, and now I am glad to see the students on this video through this media, which is highly developed. And my today's topic is related to this particular communication. I am once again welcoming all of you to share whatever the ideas what I have and thereby make use of it in order to score better marks in your classes or in your exams. I hope you will have a free feel to share with me. This is an interactive class. Therefore, any doubts you have, you can note down it and you can clarify it if possible. If I know that answer, without any hesitation, I'll try to answer them. Now, coming to the lecture, it is on the unit number 5. Unit number 5, where it is on modern physics. Modern physics, many of the students may find it difficult in physics. It is only because you try to mug up the things. But now, let me make it as simple as possible so that you can make use of them. You can try to understand them in an easier and a simpler way. So in this unit 5, that is on modern physics, it is mainly on electromagnetic radiation. So in order to understand this electromagnetic radiation, first you are familiar with what happens when light, a ray of light, a sunlight, for example, if it is made to pass through a prism. When it passes through a prism, we know very well on the other side, if we keep a screen, we get different colors. So to say, somewhere here we'll have red, and somewhere at the other points we may have, so here we may have violet, and here we have red. It is only because of the effect, what we call it as dispersion. Dispersion of light. What do you mean by dispersion? It is nothing but splitting up of light rays, white light, into its constituent colors when it is made to pass through a prism. It happens because of the phenomena, what we call it as dispersion. So that clearly indicates white light is made up of different colors, namely violet, indigo, blue, green, yellow, orange, and red, which we generally call them as Vidgaya. A simple synonym where we can make use, we can apply it and write it as violet, indigo, green, yellow, orange, Vidgaya. Violet, indigo, blue, green, yellow, orange, and red. So from this, it is clear that sunlight consists of these basic colors. So why we have different colors like this, or how these different colors are formed on the screen. And at the same time, sunlight not only consists of this 7 colors, apart from that, we have some other colors also. So what do you mean by that? We may say that we are not seeing any other colors, and we may say that we don't have any other colors apart from this. But we call these radiations as visible radiation. They are called visible radiation. And apart from that, we have other radiations also, which are called invisible radiation. So what do you mean by invisible radiation, which is not visible to our eyes. In other words, our eyes has got the limitation to see some of the radiations, and other radiations, we are unable to see them, we cannot see them, our eyes cannot detect them. And we call them as invisible radiation. So overall, all this radiations, not only this, I can say this is a very small part of this entire electromagnetic radiations. So what is an electromagnetic radiation? So on the other side, that means on either side of this visible light, we have other radiations on either side. So how the radiations are arranged, or how the radiations are classified, and what are the properties, how they are formed, all those things we are going to study now. So here we have the PowerPoint. So you can see this visible light. Visible light, when it passes through a prism, it gets dispersed, and we have violet. Of course, indigo, it is not feeble. That's why it is very feeble. We cannot detect it, and therefore it is ignored here. Otherwise, violet, indigo, blue, green, yellow, orange, all those things. And it is only the beginning to understand the radiations, which we call them as electromagnetic radiation. So how electromagnetic radiations are formed, and who is the main cause for this? In order to understand this, we have a famous Scottish scientist by name James Clerk Maxwell. So he gave a famous theory, and we call them as Maxwell's equation. According to that, whenever a charge, electric charge, oscillates, in other words, accelerates, it produces some sort of radiation. In other words, there is what we call it as, there are two possible fluctuations, or we say there is a changes taking place, one in electric field, the other one is magnetic field. Once again, let me repeat. So Maxwell said, whenever a charge is accelerated, in other words, we can say whenever a charge vibrates, because every vibration is subjected to an acceleration that you might have studied under what we call it as simple harmonic motion. So simple harmonic motion under waves you might have studied, and it is there in your syllabus. So whenever a body vibrates to and fro, it is subjected to an acceleration, and the acceleration is directed towards the mean position according to the definition. And very similar to that, and a vibrating charge also can easily be, or with confidence we can say, it is accelerated. Whenever it accelerates, there is what we call it as a change in electric field. As a result, there is a change in magnetic field also. We cannot have only one changes. Whenever the charge vibrates in a magnetic field, whenever a charge vibrates in a field, magnetic field, it produces what we call it as electric field. At the same time, the same electric field also in turn produces magnetic field. In other words, both of them will go joining their hands together, side by side. We cannot isolate them, we cannot separate them. So that is why we call such radiations as electromagnetic radiations. Now you can see the PowerPoint, and you can just note down what is electromagnetic radiation. So electromagnetic radiation, electromagnetic waves are created by vibration of an electric charge. This vibration creates a wave which has both an electric and a magnetic components, and these two components are perpendicular to the direction of propagation. So whatever when we say wave, as per the definition of a wave, whenever we say a wave is nothing but propagation of disturbance. Wave is nothing but propagation of disturbance from one point to another point. And here we have a special type of radiation, which is nothing but electromagnetic radiation, which is propagated in the form of wave. And here it is a special propagation wherein which we have two waves. So when I say wave, we should know a sinusoidal wave. And under the topic called waves, you might have studied this type of waves as transverse waves, wherein which we have the elevated portions, we call them as crests, and the depressed portions as trough. So the formation of crest and trough is nothing but transverse waves. And electromagnetic waves, I'll give you a simple sketch afterwards. Electromagnetic waves is a wave having two components. One, we say it is electric component, the other one is magnetic component. And both those components, when I say component, it is nothing but a fluctuation in the fields. And both the components, they are perpendicular to each other. One is in the horizontal plane, the other one is in the vertical plane. And both of them, it is as we find the waves propagated when you vibrate one end of the rope up and down, we find waves are formed. And the waves which are produced on water surface is also a transverse wave. Likewise, here, if I consider this as one wave, it may be due to the fluctuation in the field. We say fluctuation means the strength of the field either increases or decreases, or it changes its direction and so on. Here we say, as we move in this direction, first the field increases, decreases, and it goes in the opposite direction. Again, it increases further, decreases, and so on and so forth. So if you have this concept, instead of this, if you simply think of only the arrowheads, if you have the profile of all this, we get a wave structure. And in electromagnetic radiation, one should have two components. I've shown only one component. This may be either electrical component or it may be a magnetic component. So when you have both the components put together simultaneously and then they propagate, and whatever the new form of wave that is formed, we call it as electromagnetic radiation. So in order to understand this, so you can follow my diagram. So this is the direction along which the wave is supposed to propagate. And here first let me introduce the horizontal waves. Of course, my diagram may not be to the scale. Roughly, I'm drawing it. So to say, the vibrations. So this is one set of vibration. If I call it as a magnetic vibration or magnetic fluctuation. And simultaneously, you should show one more wave pattern, one more wave. I think there won't be any problem in understanding this diagram. It looks somewhat complicated, but it is not exactly complicated at all. So one set of wave is in the vertical direction. The other set of wave is in the horizontal direction. Both of them, they move together. At the same time, here we say the amplitude, or we can say the crest, the formation of crest of one wave and the formation of crest at the other wave take place at the same instant. In other words, both the waves travel in phase. No doubt they travel in perpendicular direction, but wherever we find the crest of one wave, there will be a crest of another wave in the horizontal direction. And whenever there is a formation of trough of one wave in one plane, the trough of another wave in vertical plane takes place simultaneously, and we say both the waves, they propagate in phase, and it is not so easy to separate them. So whatever the new form of wave that is formed, we call it as electromagnetic waves. Once again, we can look at the PowerPoint. There, electromagnetic radiation. Now it will be clear to you, I think. Electromagnetic waves are created by vibration. We can say there is some sort of vibration here, that is a charged particle. If it vibrates, it leads to two types of waves, namely electric waves and magnetic waves. In other words, fluctuation in electric field and magnetic field. Electromagnetic waves are created by the vibration of an electric charge. This vibration creates a wave which has both an electric and magnetic. If I consider this as electric field, which is generally taken as E, and this as B, magnetic field. There is a variation in electric field, magnetic field, and electric field. This is electric field, and this is magnetic field. So there is a fluctuation, and as a result, we say that waves propagate from one end to another end. So in order to understand this, I've just made a simple activity, and even you can try on your own in order to understand, because in the diagram it is not so clear, and even my activity may not be that perfect, but just to give an idea. So here we have one sort of waves in this direction, vertical direction, and here this is another direction. Both are perpendicular to each other. So we have a set of waves in the vertical direction and another set of waves in the horizontal direction. If you consider one as the vertical, the other one will be horizontal. And here, as I told you, whenever there is a formation of crust, the crust will be formed at the same point in the other plane, and the trough is formed here, and the same trough is formed on the other side. So crust and trough, if you paste it, it will be better. Okay, you can somehow manage. So this is what we call it as the waves, they move in this direction. The waves, they move in this direction, crust and trough. Here the animation is not given. Now, for your information, I can tell you, there are plenty of videos which are available, and you can just go through them in YouTube. There are so many other videos that are also available. Instead of wasting your time in various other programs, watching other programs, you concentrate on the programs which are there, which will be highly educative. Now, what are the properties? And before going to this, let me tell you what happens to the wave, in what way the waves are differentiated one from the other. So there is in wave, the topic called the wave, we have V is equal to n lambda. This is a famous equation which we come across, and you must have derived this equation also, where the letters, they have their own significances or their own speciality, where V stands for velocity of the wave, n stands for frequency of the wave, and lambda stands for wavelength of the wave. And you might have studied in the previous definition, frequency, it is number of oscillations or number of cycles completed in 1 second. Wavelength, it is nothing but the distance traveled by the wave during the time particles of the medium complete one oscillation. So here if you say this is the wave, and this is the length of one full wave, and it is taken as lambda. And how many waves are formed in 1 second? Or if you just stand at one point and count the number of waves that are crossed in 1 second, that gives you the frequency, number of cycles completed in 1 second. And the product of frequency and wavelength gives you the velocity of the wave. Now, in this particular topic, electromagnetic radiation, we use the symbols C is equal to mu lambda. Only the letters are changed, but the meaning is one and the same. Where C stands for velocity of light. You might have used the famous equation, Einstein's equation. E is equal to mc square. The same C is taken over here, or the same C is taken in this equation. E is equal to mc square, where c stands for velocity of light and nu stands for frequency of the radiation, lambda stands for wavelength of the radiation. In electromagnetic radiation, we have different types of radiations. We have gamma radiations, gamma rays, and we have X-rays. We have ultraviolet radiations, infrared, visible radiations. Next, we have infrared radiations. Then we have microwaves. Then we have radio waves. So, in what way they differ from one another? That may be another question. In what way one, that is gamma rays, they are different from X-rays, and X-rays are different from ultraviolet radiations, and so on and so forth. It is only there is a difference in what is known as the frequency of the wave. When I say the frequency, not only the frequency, there is a change in the wavelength also. Out of this, let me give you one important point, thereby you can remember the other one. Out of all electromagnetic radiations, gamma rays are said to have very small, in other words, least wavelength and highest frequency. Gamma rays, remember one phrase, and thereby you can build up the sentence on your own. Gamma rays, they have the least minimum wavelength. At the same time, they have higher frequency. So in this equation, when this is very large, automatically this should be very small. Or when this is very small, this should be very large. Thereby, the product of the two, frequency and wavelength, is constant. That is what we call it as velocity of the wave, which is equal to 3 into 10 to the power 8 meter per second. In other words, we can say this value, instead of expressing in meter, I can express in kilometer, and there I say velocity of light. Light travels a distance of 3 lakhs kilometers in 1 second. You can find out what is the tremendous value, and that tremendous velocity, that is called celeritas in Greek. It's in Latin, it seems, and that is why we say c. Many of us may not know why this C has written instead of V. It is only from the Latin term celeritas, which is nothing but tremendous velocity, and the first letter of celeritas is taken as a C. So C, velocity of all radiations, whether it is gamma or ultraviolet or invisible or radio waves or whatever may be the radiation, all radiation, they travel with the same velocity, which is nothing but 3 into 10 to the power 8 meter per second. And all these radiations, they have two components which are perpendicular to each other, mutually perpendicular components, namely electrical component and the magnetic component. They travel with a high speed and they travel along a straight line. And they travel even in vacuum. They don't require a material medium for its propagation. And as a result, we say that electromagnetic radiations, they are non-mechanical waves. You might have heard of the classification of waves based on medium, whether a medium is required for a wave or not. Some waves, they definitely require a medium. Without medium, waves cannot propagate. We cannot think of water waves without water. So water wave is a mechanical wave. We cannot produce a wave on a rope without a rope. So rope is a must. Only then we can say waves can propagate. Therefore, waves produced on a rope is also a mechanical wave. Whereas electromagnetic radiations, they are not bothered about any sort of medium. They travel in vacuum, because we know for certain sun and earth, in between, we don't find any medium at all. No doubt there is a limited zone which we call it as Earth's atmosphere, and there is air particle, in other words, gases are present only up to limited distance. But in between, the rest of the portions, the rest of the gap between sun and the earth, we find vacuum. and even then we get sunlight. And therefore, we say that light can travel even in vacuum. Not only light, gamma rays, X-rays, and all other electromagnetic radiations, they can travel through vacuum also, and they can propagate through different materials to different extents. Now, let me explain this relation. C is equal to nu lambda, where C is known as velocity of light. The other term for that is celeritas. Nu is the frequency of the wave, and lambda is the wavelength of the wave. So this equation is important equation in order to study this electromagnetic radiation. As you know, so I've given you a simple sketch, something like a seesaw. So gamma, so frequency, that is nu, when it is very large, and lambda is very small, you know what happens there. When we cannot think of both being a higher value or larger value, one increases, automatically the other one decreases. So I've given you an effect, thereby you can remember this value. When nu increases, lambda value will be very small. On the other hand, when lambda is very small, very large, nu will be very small. So I think this comparison will be useful for you in order to explain what is known as the electromagnetic spectrum. So electromagnetic spectrum, what do you mean by electromagnetic spectrum? Something like a PT class, where in PT class you might have formed a straight line of students, or students standing in a row, and we don't find a random arrangement, we find some systematic arrangement. Generally, the shortest person will be in the front and the tallest person will be at the back. Thereby, we say there is an orderly arrangement according to the height, not according to the weight. So, whenever we find some orderly arrangement, we say there is a system. And in the same way, instead of randomly arranging all the radiations in the form of a table, we arrange them in a systematic way. It is something like periodic table. I don't know whether you have learned about periodic table or not. Periodic table, we find the systematic arrangements of elements according to their atomic number. And in the same way, here we follow some system, and the system that we adopt is we are arranging them in the order of their frequency or of the order of the wavelength. Now, if I say the frequency at this point is maximum and the frequency is minimum, so this may be one order. At the same time, I can say wavelength is minimum for such wave, whereas the wavelength will be maximum for such waves. And you try to accommodate all possible radiations which are available, starting from gamma rays to radio waves. Gamma rays, they have the least wavelength and maximum frequency, whereas radio waves, here we have gamma rays at this region, and here we have radio waves at this region. And twice. One side. So the radio waves, out of all electromagnetic radiations, radio waves, they have maximum wavelength but minimum frequency. So if you try to arrange them in the form of a band, an orderly arrangement, that is why we find electromagnetic spectrum. First, let me explain and let me show in the diagram also. Electromagnetic spectrum, the orderly classification of electromagnetic waves according to their frequencies or wavelength, is called electromagnetic spectrum. Let me repeat, the orderly classification, in other words, we can say the arrangement also, the orderly classification of electromagnetic waves according to their frequencies. What I mean is, it may be in the increasing order of the frequencies or increasing order of wavelength, but in a particular direction. Such an arrangement, such a band, we call it as electromagnetic spectrum. Let me give a simple diagram for this. So here we find gamma rays. Okay, this is called electromagnetic spectrum. We can use this as a standard table or a band, which we call it as electromagnetic spectrum. This is not electromagnetic spectrum. I'll come to this point later on. Here we have cosmic rays. Of course, cosmic rays, cosmo means outer space. There are some radiations very similar to gamma rays. They are coming from other stars, other part of the universe. They reach even Earth also. So they have very high frequency. And next we have gamma rays. The frequency is slightly decreased. X-rays, the frequency is still lower. Ultraviolet rays, they have still lower frequencies. In other words, as we go from left to right, we say that the frequency of the radiation decreases. At the same time, wavelength of the wave will increase. Wavelength here, it is very, very small. Small waves on this side, whereas very large waves on the right-hand side. In other words, radio waves, they have higher frequency when compared to other radiations like gamma, X-rays, ultraviolet, and so on. And here, there is a small band or a column given here, which corresponds to visible light. That is, that can be sensed, that can be detected by human eyes. And here it starts from violet and ends at red. It is only a stretched, zoomed portion, because here we cannot accommodate to the entire portion and we cannot explain them. That's why this portion is separately zoomed out. And here we have a violet color, and this side we have red color. And violet light has got a higher frequency, lower wavelength, whereas red color, they have lower frequency and higher wavelength. So that is only a patch, in other words, bands which is shown here. And here, this is in the reverse order. Here the wavelength, it is in the increasing order of the frequency. The frequency here is very low. As we go from this side to this portion, the frequency increases. Radio waves, they have very low frequency, but if I express in terms of the wavelength, it is of the order of 10 to the power 2. That means in terms of 100 to, we can say it is of the order of 10 to the power minus 1. That is in terms of millimeter. Okay, and here we have 10 to the power minus, that is in terms of, sorry, here it is in terms of centimeter here, and this is decimeter. So here we have millimeter and so on and so forth. So here the wavelength is 10 to the power minus 12 meters. Gamma rays, they have very small wavelength. And in order to give a comparison, the sizes of the wavelength, here nucleus nobody has seen, but we can just imagine what may be the size. So gamma rays, they are of this order of nucleus of an atom, whereas X-rays, they are almost the size, in the order of the size of an atom. And here we have some viruses. Okay, the viruses are slightly bigger than atoms. And here we have bacteria, then we have animal cells and plant cells, and this is the pinhead. It is of the order of some few millimeters. And here we have some insects, bees, and human size in terms of meters, we can express in terms of meters. And football ground, football field, it is of the order of a few meters, or in terms of kilometers also, we can say. So here this is also an electromagnetic spectrum. Here it is expressed in terms of the wavelength. You can have just comparison. Wavelength are very large. On this side, the wavelength is very small. The distance between two consecutive crests is large. As you go towards the right, the wavelength decreases. The distance between the consecutive crests decreases. And the same way, distance between any two consecutive trough also decreases. Thereby, we have electromagnetic spectrum starting from radio waves to gamma rays in the decreasing order of their wavelength, or we can say in the increasing order of the frequency. So what are the properties of electromagnetic radiations? Already I told you, electromagnetic radiations, whatever the explanation given so far can be summarized, and that can be taken as the properties of electromagnetic. Electromagnetic waves, or we can say radiations. So these electromagnetic radiations that travel in straight line. All electromagnetic radiations that travel in straight line. They travel with a tremendous velocity, same velocity for all radiations. There is no disparity. In other words, if you have a track, running race track, and put gamma rays, X-rays, ultraviolet radiation, visible light, visible infrared, and so on, and if you conduct a running competition, running race competition, who will get the gold medal? Means some of you may say it is gamma rays. Not at all. All of them will move together, joining their hands. That is the meaning. All radiations, they have the same velocity, equal velocity, which is equal to the velocity of light, which is 3 into 10 to the power 8 meter per second, or 3 lakhs kilometer per second. And all electromagnetic radiations, as I told you, they have crust and trough. Therefore, the formation of crust and trough gives the evidence that the electromagnetic radiations are transverse. If it is transverse, it is not, what is that? Fill in the blanks. It is not longitudinal. They are not longitudinal waves. Longitudinal waves we have studied. Longitudinal waves, sound waves are longitudinal in character, whereas light waves and all electromagnetic radiations, they are transverse in nature. Now let me summarize them. Let me give one by one and explain then and there. So properties of electromagnetic radiation. Number one, all electromagnetic radiations do not require a material medium for their propagation. In other words, they are non-mechanical waves. They are non-mechanical waves. Number two, all electromagnetic radiations travel along a straight line. All electromagnetic radiations travel with a velocity 3 into 10 to the power 8 meter per second in air or vacuum. So when I say 3 into 10 to the power 8 meter per second, this is not the velocity in all medium. Light can pass through different media like glass, water, diamond, air, and so on and so forth. Only in air or vacuum, that too in particular we can say it is in air or vacuum, and this value is given by C is equal to 1 by square root of epsilon naught into mu naught, where we call them as permeability of free space and permittivity of free space. That is related to the terms electric field and magnetic field. Don't worry about this equation, but we say that all radiations that travel with the velocity of light in air or vacuum, which is nothing but 3 into 10 to the power 8 meter per second. Not only that, all electromagnetic radiations are transverse in nature. Both the electrical and magnetic fields that travel perpendicular to each other, and both the waves, they are transverse in nature. As a whole, we can say all electromagnetic radiations, they are transverse in nature. They are not deflected by electric and magnetic field. There are certain radiations which we call them as alpha rays and gamma rays, alpha, beta. In radioactivity, you might have studied, if you have a radioactive sample placed in a lead box, and if you apply electric field alpha rays, they will be deflected towards the negative, and all alpha rays, and this is beta rays. Alpha rays, they will be deflected towards the positive plate, and beta rays will be deflected towards the positive plate, and alpha will be deflected towards the negative plate. It is because alpha particles, they carry positive charge, beta particles carry negative charge. Alpha particle, generally we say it carries 2 positive charge, and thereby they are deflected towards the negative. At the same time, you might have drawn one more set of rays, they go undeviated, which is the reason we say that they are not deflected by electric or magnetic field, because they do not contain any charge. It is only the disturbance, the radiation, only the field is propagated, and they are neither deflected by positive nor negative plate or negative field. In other words, even if you keep some magnetic field also, they do not undergo any deflection at all. So they do not deflect by, they are not deflected by electric or magnetic field. There is a special type of property which is characterized only by transverse waves, which we call them as polarization. There is a special property. Properties like reflection, refraction, diffraction, polarization. There are so many properties. Light, if you think of light, for example, light can be reflected, it can be refracted, it can be interference. There is one more phenomena which you call it as diffraction, and there is another property which you call as a polarization. So even longitudinal waves, they can be reflected, refracted, they can undergo refraction, interference. But this particular property, polarization, is noticed only in case of transverse waves. Only in case of transverse waves. So light waves, when I say light waves undergo polarization, it is applicable for all other electromagnetic radiation. So once again, coming to the properties of electromagnetic radiation, all electromagnetic radiations do not require a material medium for their propagation. In other words, they are non-mechanical waves. All electromagnetic radiations travel along straight line. The property is also called rectilinear propagation. Rectilinear propagation means propagation along a straight line. And all electromagnetic radiations travel with the velocity which is equal to 3 into 10 to the power 8 meter per second in air or vacuum. All electromagnetic radiations, they are transverse in nature. At the same time, all electromagnetic radiations are not deflected by electric or magnetic field, and all electromagnetic radiations can be polarized. And in the examination, if you get a question like find the properties or give or mention some of the properties of electromagnetic radiations, it may be for 2 marks or it may be for 3 marks. Whatever may be the number of marks, accordingly you can choose the properties whichever you know at that time. The electromagnetic radiations, they have momentum. So when I say momentum, you are familiar in physics. Whenever a body of mass m moving with velocity, the product of mass and velocity gives you a momentum. And all electromagnetic radiation, this particular property gives this evidence for photoelectric effect. That means when a light of suitable frequency or wavelength or suitable energy in general is made incident on certain photosensitive materials, electrons are emitted. Electron is a particle. And in order to eject that electron or in order to emit that electron, some amount of energy is given. And you have to imagine that light consists of particle also. There is another theory which you call it as particle nature of light. But Now we can take it for granted that all electromagnetic radiations, they impart momentum. In other words, they have momentum, thereby they are capable of emitting electrons from the solids or from the metals. Now, coming to some of the applications of electromagnetic radiations. So gamma rays, so each radiation has got its own application. Number one, gamma rays can cause, at the same time, they are used in treatment of cancer. That is, in high doses, very large amount of radiation, intense radiation, they are made to incident on a body. Gamma rays can kill normal cells and cause cancer. At the same time, gamma rays can be used to kill mutated cells. So gamma rays, they are boon as well as bane. They say that there is advantage as well as disadvantages. Advantages, it is used to treat cancer patients. At the same time, whenever a person is exposed to gamma rays to a greater interval of time or a larger period, then he may suffer from cancer also. X-rays, as you all know, X-rays are used to detect the fractures in bone or bone. Whenever there is a breakage in the bone, we can make use of X-ray scanning and we can detect it. X-rays, they pass through the flesh portion, whereas they do not pass through the hard bone portion, and thereby we can differentiate the bone portion as well as the flesh portion, and whenever there is a crack, easily it can be detected. X-rays, they are used in crystallography. When I say crystallography, it is a study of crystals. That is a special topic in physics, how the crystals are formed, how the atoms and molecules are arranged in a crystal, what are the different arrangements. All those things, they are studied under crystallography, and in order to study them in detail, X-rays are used. At the same time, X-rays can damage cells also, and that is why this X-ray technicians, which we call them as radiographers, they can take precautions, including wearing lead aprons. We can find some gown like a dress while taking the X-ray scanning. So they have to use some apron, which is lining, having some lead lining, and sometimes we may watch them standing behind a lead screen so that you will not be exposed to the X-rays. So X-rays damage the cells and cause cancer. This also can cause cancer. Then radiographers, precaution should be taken, that is including wearing lead aprons and standing behind lead screen to minimize the exposure. Ultraviolet radiations. Simple terms, I can say, they are used as germicidal. That means to kill germs and kill bacteria and viruses in water, and even it is used in air purifier. Air can be freed from this bacteria and other things. And in many of the hotels and restaurants, we can find some violet color lights which are on, which will be detecting, and sometimes they'll be acting as a repellent also of the flies and insects. So they are used in therapeutic properties. Sanitary and therapeutic properties have marked effect on architecture, engineering, and public health, and have done so throughout the history. So ultraviolet radiations, they are used as a germicidal, destroying bacteria, viruses, molds in air, in water, and on any other surfaces. So ultraviolet radiation, it is one of the important radiation. One has to, at least for a few minutes, should be exposed to sun, because vitamin D is very important for our survival. It can be synthesized in our body whenever we are exposed to ultraviolet radiation. But a mild ultraviolet radiation is required, not a powerful ultraviolet radiation. For this reason, you might have seen even small children also, they are kept in morning sunrise time, thereby they will have the growth and they will be having strength also. So ultraviolet radiation synthesizes vitamin D in skin, controls the endocrine system, and it is a painkiller. It is used as a personal air purifier and in swimming pool technology. They are used to detect. So this is one application of ultraviolet radiations in banks and all. In order to detect the real note and the forged notes, they will expose the given note to ultraviolet radiation, and there will be some glow here and there, and thereby they can easily make out whether it is a real note or a fake note. Nowadays, it is quite common that we cannot distinguish with our naked eyes or normal vision. It can be detected with the help of only ultraviolet radiation. What are the dangers? Overexposure. Already I told you, overexposure to ultraviolet radiation, A and B. There are different classifications, slightly variation in the energies. Damages surface cells and eye. This is the main reason why you should not see the sun during the solar eclipses, because there will be a lot of intense ultraviolet radiation which cannot be detected, and you will not be tempted to close your eyes, but you will be watching the sun for a longer time. Within no time you will be losing your sight. It is only because of the effect of ultraviolet radiation. That is why they make use of some filters wherein which ultraviolet radiations can be filtered and we can admire the beautiful scene of the solar eclipse. There is a problem in the current sunscreens which protect against skin burning from ultraviolet radiations, but gives inadequate protection against free radial damages caused by ultraviolet A. Sun exposure for the skin is best restricted. This is only the duration, because early morning it is good, not at the midday, because there will be intense radiation which will lead to other complications, and even at the time of or just before the sunset we can be exposed to the sun and thereby more ultraviolet radiation. We can fall on it, and vitamin D can be synthesized to a greater extent. Infrared radiations. Infrared radiation, any object that radiates heat also radiates infrared radiation. That means whenever a body is heated up, it gives not only heat radiation, it gives out infrared radiation also. Infrared radiation is absorbed by all materials and cause heating. Infrared radiations, they are used in some binoculars, night vision binoculars. That means during night times also we can make use of those binoculars and we can see the images even if it is dark. Even in the absence of sunlight, images can be seen with the help of binoculars. It is visible in daytime as well as in nighttime. So the police people also, they use this ultraviolet radiations to catch criminals, and in army to use to detect the enemy campers. Infrared radiations, they damage the cells to some extent, because overexposure to infrared radiations, they can burn the cells. Microwaves. Nowadays we cannot live the present stage, we can say. It is very difficult to live without mobiles, without TV, without radio, and so on and so forth. It is only because of this microwaves. We are going to study them after a few minutes, in the next chapter to come. We are using microwaves in the satellite signals. Frequency of microwaves pass through the atmosphere and clouds. Microwaves, they are used in microwave ovens. Here, the microwaves are absorbed by water molecules, and these water molecules become heated up, thereby it is useful in cooking the foods, thereby it can cook the foods. Okay, at the same time, microwaves, they have little bit of danger also. Microwaves are absorbed by living tissues. Internal heating will damage or kill the cells, and you might have received some WhatsApp messages. Do not use your mobile for a greater time. It is only because some of your parts, sometimes brain or the internal part of your ears, can get damaged when it is exposed to the microwaves. You may say that nothing is reaching because you are not able to see them. But only after the failure, after the damage, you can realize and you can understand. So it is better, prevention is better than cure. Likewise, even radio waves, they are also used in this television signals, FM frequency modulated radio waves. So these waves, they have a short range. That means they can be traveled along a straight line, but this medium waves, this MW waves we call medium waves, they travel larger distance. This is used in radio communication. It is only because they get reflected from the layers, which we call them as ionosphere, which is present in the outer atmosphere. So this radio waves, they play a major role in communication. So to begin with, gamma rays, we can use gamma rays for gamma rays. This is used in curing cancer cells. X-rays, they are used for scanning and as well as crystallography. Then ultraviolet radiations, they are known as germicidal. That means they use to kill the germs. And visible light, as you all know, it is used for various purposes. Without this visible light, without seeing, this entire world will be dark for us. Then we have infrared, which is a heating waves, which can be used for some treatment also, painkiller, we can say. And we have microwaves. They are used for communication as well as for cooking as well as for communication. Similarly, radio waves are also used in communication purpose. And the radio waves, they are useful in order to study this nature also, because what is happening in the outer world, so to say, in the universe, there are so many phenomena taking place daily, and they are not very close to us, they are very far off, which we express them in terms of light years, not in terms of 1 or 2 light years, several thousands of light years. There are some lights coming, the radio waves, they are coming from the outer stars or the outer celestial bodies, and in order to study their origin and other aspects, they make use of radio wave radars, detectors, and there they study what is happening, and they are going to study about this black holes and so on and so forth. In order to study them, this radio waves, they help us a lot. So just to summarize, radio waves, they are formed only when a charged particle vibrates. Whenever it vibrates, it gives out to 2 types of waves, namely electrical waves and magnetic waves, or fluctuation, electrical magnetic fluctuations, which are perpendicular to each other. They travel with the same velocity, perpendicular to and the vibration is perpendicular to the direction of propagation. Thereby, radio waves or electromagnetic radiations are transverse in nature. They travel with a tremendous velocity equal to the value of velocity of light, which we call it as 3 lakhs kilometers per second, or 3 into 10 to the power 8 meter per second. And all electromagnetic radiation, they don't depend upon the medium. Even in the absence of medium, they can propagate, and we call them as non-mechanical waves. They travel along straight line. They do not require material medium. they undergo reflection, refraction, polarization, diffraction, and so on and so forth. So these are some of the properties. And all electromagnetic radiation, just imagine for a few minutes or just close your eyes and see, if all electromagnetic radiations were absent, how the world would have been. You would not have seen anything. You would have been only in dark without seeing anything. But we have the gift of light and electromagnetic radiation, and we should be grateful to Maxwell because he took the initiative to give this theory on electromagnetic radiation. And later on, the scientist Hertz also worked on it, and he generated for the first time this radio waves and propagated the signal. So we will be studying them after few hours or in the next session to come. Thank you very much. So if you have any doubts, you can ask me. Welcome the students.